Yeah, Sean, thanks for having me. I really appreciate it. I know we spoke offline, just like a handful of times, but I always am watching what you're doing, and if I can understand if it's in English, then like obviously that helps my understanding a little bit more. But yeah, you're always putting out great stuff, and I always really appreciate the conversations and stuff that we can have. So thanks for having me.
Yeah, man, it's great. And I had the pleasure to chat with Matt on your guys' podcast recently.
Hmm.
Maybe tell me a bit about that. How come you guys started the podcast? Tell me a bit about it. What are you trying to achieve with it? It's a great show, and you have fantastic guests on. So uh, people listening to this should definitely check it out.
Yeah, yeah. So Matt DeRoche uh, reached out to me, um, I don't know, a few months ago, and he had followed me on my Critical O2 Instagram page, where I just try to, like synthesize as much research and concepts and stuff like that as possible to help people, like coaches and athletes, understand physiology a little bit more and then use that and apply it to their training. So he was like, oh, Phil might be a good guy to team up with for co-hosting a podcast. So we just started recording some episodes. Mainly him and I we'll do one episode a week where we sit down and just like kind of do a deep dive into like literature and like concepts in physiology and more application towards sport performance and all of that. And then he independently does all the interviews with people, just because as a PhD student, it's really hard to be able to schedule podcasts and stuff. Like for instance, today I had to wake up at like 4 a.m. in order to be able to coordinate this with you. So I can't even imagine like the logistics that he goes through, that you go through in order to actually have consistent good guests on. So basically what happened was he reached out to me, was like, hey, I have this idea, I want to do a podcast. Him and I kind of hit it off right away. He is an extremely intelligent guy, super fun and easy to talk to. So um, I think we do a pretty good job of, like diving deep into the weeds and then some, resubmerging and surfacing and trying to, boil down these concepts. And he does a good job of, I mean, your guys' the podcast that he did with you is really, really good. And your philosophies on training, I think, are align a lot with what him and I try to take away. So, yeah, it just kind of started on a whim. And the name of the podcast is Oxidative Potential. With the idea that it's like I have my PhD is in mitochondrial physiology and how the mitochondria respond to dietary and exercise interventions. So
Mhm.
I have a great, probably maybe an over appreciation, but probably not for the mitochondria. And that's kind of where everything kind of stems around. It kind of leans a little bit more to the performance side of things, but again, like we have so many different interests. Like he was a fighter back in the day. So he's got, fighting background, fighting interests in combat sports. Him and I both really like, strength sports. So we talk about a lot of things, and it's all for the betterment of sports performance. So
Yeah, like I said, it's an awesome podcast, and everybody should go check it out. I want to talk about mitochondria. It's funny that you mentioned that because we obviously got to know each other around the Moxie monitor, and so
mhm.
talking about oxygen kinetics and all that good stuff. I just recently had a little kind of a little weekend course that I gave. Somebody came from France to kind of see my process, see how I work, and how to apply it on his end. And
Mhm.
we talked a lot about lactate, and that just kind of sparked in me the idea of, you know what, I actually don't understand those models as well as I could.
Mhm.
I had a really cool chat with a coach just via email, and I had posted some of my lactate values to a bunch of different tweets, and he essentially just built a predictive model around my performance using my lactate measurements and rates of oxidation and I guess production. We can't measure those directly, but we can infer them from different types of efforts. So that was
Right.
really interesting. And the interesting thing is that it kind of models like the W prime
Mhm.
in the critical power, and the O prime, if we want to speak of it, something that I've
Right.
noticed on severe domain efforts on the bike, for example. If I do a 3-minute, well, my bicep or my shoulder is going to desaturate at a certain rate, and if I do a 12-minute test, then it's going to desaturate, but not as fast. So
Mhm.
those lines kind of work like those W or O primes or lactate prime, whatever you want to call it. So
Yeah.
I figured, you know what, I need to dive into this side of things a little bit more. So I should get it tomorrow. I just ordered The Science of Winning. I think
Okay.
it's Albrecht's book, and I guess it goes into depth on the whole lactate business and the modeling that they've used to kind of, I guess, model human physiology and how it functions. I just find it fascinating how all those different models start from a different perspective, but kind of all end up in the same place, and they don't superimpose on each other perfectly, but it's pretty close. And
Yeah.
I find that fascinating.
Yeah. I it, my bias is going to show here, but it all comes down to the mitochondria.
Mm-hmm.
So, and let me explain that. So, whether you're looking at oxygen, whether you're looking at lactate, um, those different models, they like, and so this is something I've been thinking about a lot about lately because Andrew Feldman and Brett Kirby and I are working on a paper that is comparing lactate values and SMO2 slope values
Mm-hmm.
during progressive step tests. And essentially what we see is a mirrored inverse or a mirrored reflection of lactate values on one side and then SMO2 slope on another.
Mm-hmm.
So this is something that we're thinking about. And if we start with lactate, we're measuring lactate in the blood. So we're measuring kind of the net flux of lactate within the blood during exercise, right? Higher values obviously mean that there's more lactate flux, higher production versus lower clearance. Where's that lactate actually coming from? The lactate is coming from the skeletal muscle, and in particular, the lactate is coming from a conversion of pyruvate to lactate from glycolysis.
Mm-hmm.
Where mitochondria come in here is that the mitochondria are generally the ones that are oxidizing pyruvate, right? So as exercise intensity continues to increase, glycolysis continues to increase, and then eventually you get to a point, and this isn't it, perfectly scientific, but you get to a point where pyruvate is essentially oversaturating the muscle. The mitochondria can no longer uptake that pyruvate fast enough that is being created. So
Mm-hmm.
that is almost immediately being converted into lactate. Lactate can then be shuttled out of the skeletal muscle where it can be uptaken by, say skeletal muscle fibers that have more mitochondria, can deal with lactate a little bit better and all of that. So in the beginning, right, before your first rise in lactate, that's kind of what's happening is your body is able to deal with the increases in lactate production via kind of local uptake of that lactate, reconvert it into pyruvate, and then from there it can go into the mitochondria and be oxidized. Once you get to a certain point, that lactate can no longer be uptaken into, different skeletal muscle fibers and those sort of things. So then it starts to quote unquote seep into the blood, where again, it can be used in different places. It can be used in the liver, it can be used in the heart. But you see, kind of that rise in lactate with increasing intensities. And again, it's most likely due to a limitation of the mitochondria being able to actually uptake and oxidize the pyruvate that is actually being formed from glycolysis. So then how does oxygen play into this? Oxygen is you can jump in whenever you want, but oxygen is the final electron acceptor, right, within the electron transfer system within the mitochondria.
Mm-hmm.
So really the only place in your body that oxygen is actually being consumed is within the mitochondria, and your skeletal muscle, especially during exercise, is the ones that are consuming all the oxygen. So if you have a limitation of the mitochondria to uptake pyruvate, which then converts things to lactate, that means that essentially there is a limitation of your mitochondria to then fully continue to oxidize oxygen, or at least they would be like very tightly coupled.
Mhm.
So the amount of oxygen that you're utilizing is going to be directly related to your mitochondrial function. And then once that is kind of surpassed, then that's when you're going to start to see, this conversion from pyruvate to lactate. So then from a modeling perspective, if we take another step out, it makes sense that then, like the oxygen critical power lactate model of bioenergetics, or, of performance, whatever you want to call it, would look very similar because they're all interrelated. And I guess I haven't related critical power, but critical power is just then the mechanical, or like the mechanical conversion of all of that energy that is being synthesized from oxygen, which is related to lactate, into mechanical energy. So
Yeah.
it's just a little bit further down the chain, but all of them are very intimately tied together, right? It all comes back to the bioenergetics, the mitochondria, and then, from there, it would make sense that, like they should all look the same, but they're not going to happen on the same relative time scale. There's always going to be a little bit of, say, lag or differences in between because of the different steps in time it takes to, say, measure lactate in the blood, measure oxygen consumption at the muscle, or measure power output at, like, say the pedals or something like that.
Yeah, that makes total sense. And I think it was a great summary tying everything together here. One thing that helped me link the oxygen side to critical power is the determining factors of critical power.
Mhm.
And I think if I remember correctly, the one with the highest correlation, which is I think it's a 0.94, is the contact surface between capillaries and type 1 fibers. As
Okay.
in, the more surface of exchange you have between the blood and the muscle, the more oxygen you can pass through, right?
Mhm.
Because I guess the opportunity for diffusion is bigger, and that has the highest correlation to critical power as a performance metric. So
Yeah.
there's other ones. There's this proportion of type 1 fibers, but that's a little bit lower. I think it's around the 0.8 mark. And then there's capillary density, but then the highest one is the surface of exchange between the capillaries and the fibers, which again kind of clicked in my head because now we have that not a causal link, it's a correlation, but
Right.
it's a very high correlation value. And since we understand that above critical power we can no longer maintain internal homeostasis, we lose that ability of keeping all the processes kind of in check. Whereas over critical power, there's kind of a runaway effect where, well, we can't maintain that balance internally anymore. And to me, that's primarily related to oxygen, as in the most oxygen you can bring to maintain that balance, and then beyond which point you can no longer maintain that equilibrium.
Yeah. That's something that's been talked a lot about in, like, the literature of, like, exercise physiology. Is if you look at any review, past review, whatever it is, the what a lot of people think is that your body's ability to deliver oxygen is the biggest limiting factor in endurance performance. Like, your heart
Mhm.
just doesn't have the ability, to deliver as much oxygen, or enough oxygen. Whereas your mitochondria seem to be overbuilt to actually use and utilize oxygen. And obviously that depends what sort of populations you're looking at, and all of that. But yeah, if we kind of look at it from that lens, then by increasing type 1 fibers, which are, have the ability to use more oxygen, increasing capillary density, so we can deliver more oxygen, and then, having that greater interface, that greater surface to surface contact, is going to allow greater diffusion, of lower oxygen gradients across, that barrier. And then we can have, quote unquote, more robust mitochondria that then allow for more pyruvate to go into the Krebs cycle, which can then be used in the electron transfer system. So then we can avoid, accumulation of lactate for longer periods of time.
Yeah, and I guess delay it or push it to the right, push it down the line.
Yeah, exactly.
The way I understand it, and I don't currently have access to the fat oxidation metrics, but that should come soon with VO2 Master, hopefully.
Right.
I know they've been working on that feature for a long time, and Peter said that they will not release it until it's actually ready and kind
it's
of
going to work really well
and everything. Exactly.
Yeah.
So we're waiting patiently for that. But in the meantime, what I've seen from Inigo San Milan's work and other people's work as well is that almost inverse relationship between fat oxidation and lactate, where if you see a dip in lactate in the early stages of a step test, for example, you can assume that there's an uptick in fat oxidation if you did have that curve. What do you make of people who start at a very low intensity, say it's a 1 out of 10, they're at 100 BPM on the bike, and their lactate levels already go up from, say, I don't know, 0.9 at rest to like 2 at, again, maybe 0.8 watt per kilo, something really that should be virtually really, really easy, but they don't seem to have any kind of baseline, I guess, at least not relative to their resting values. It just goes up right away. Do you have an idea as to what this is due to? What is causing this instant rise in lactate?
Yeah, that's a really good question, and something that I have less experience in the applied, like, testing athletes, testing, different populations, especially when it comes to lactate. So
maybe let me flip it the other way. When if you have studied it or have seen it in your studies and your research, what does mitochondrial dysfunction look like from maybe an oxygen perspective?
Yeah, that's also a really good question. So that's something we talk about in my lab all the time, is like, in the early stages of measuring mitochondrial the function, dysfunction, those sort of things, what people were coming out with was this idea that there was inherent mitochondrial dysfunction that led to metabolic disease. And what they meant by mitochondrial dysfunction was that the mitochondria just simply couldn't respire as strongly as someone who was trained or fit or whatever it is. However, that has kind of been met with conflicting evidence now. So for instance, I have a group of high fat diet mice that are severely overweight, obese, have glucose intolerance, so at all the markers of metabolic disease, and they actually have much better respiring mitochondria compared to their low-fat diet counterparts, who also exercise and do all this other stuff. Granted, that's a mouse model, and mouse model might be a little bit different than human model because, in a human model, the development of metabolic disease takes, it used to take 20, 30, 40 years. Like, that's why type 2 diabetes was called adult onset diabetes. It's becoming more prevalent, and it's becoming, developed more quickly. But I think that using a mouse model can be challenging because, we're not seeing that inherent mitochondrial dysfunction. Like, when we use a quad to measure mitochondrial respiration, most of the time it's actually better than than low fat diet, quote unquote, healthy animals. So I guess getting back to your question though, I would say that perhaps for people who are naive to exercise is an incredible stress. So with that, so what you trying to connect the dots here. So with exercise physiology, generally what we see, right, is a really, really easy exercise. There should be an uptick in fat oxidation. That fat oxidation is going to peak at some point, and then there's going to be kind of a decrease in fat oxidation with an increase in carbohydrate oxidation, right? That's why we measure RER. That's why we do other things like that. But what we see is that one of the reasons why we see that downturn in fatty acid oxidation is due to constriction of capillaries and blood vessels in the adipose tissue. So you're still actually breaking down fat. You're just not able to transport it out of the adipose tissue. So perhaps people who have kind of that adverse reaction, and don't really have that like lactate of 0.9 for an extended period of time, perhaps the stress of exercise is so great that they're actually vasoconstricting at the adipose tissue. So then they have to start relying more on carbohydrate oxidation almost immediately upon the start of exercise. That would kind of be my hypothesis with it. And without actually, talking to Inigo or anything like that, like that, I listened to a really good podcast with him. Who was it? It was one of the
On the drive.
Yeah. It was on the drive. So it was a really good, conversation. And, Inigo obviously uses a lot of lactate measures and all of that for metabolic phenotyping and stuff. And it certainly is, in that regard, I think could be a good measure of, like what's going on, from a metabolic perspective, right? Because if you're measuring the presence of lactate, you're not measuring it, like, would probably see similar RER changes as well. Like these are the type of people that would probably go from like an RER of 0.8 to like 0.95, like immediately upon exercise. And then it never goes back down. And I have seen that before. I've seen that, and it could be due to a couple of different things. Like, I definitely have a tendency to hyperventilate whenever I'm, doing VO2 tests and stuff like that, just because for some reason I just like think about breathing more, and then I just blow off more oxygen and CO2, and then that results in higher RER. But if that perception goes away and they still have a high RER, then I think that could be an explanation for why it might be happening.
So you said you're studying the mitochondrial development, function, and improvements through exercise and diet interventions. From your perspective, is there a difference to the stimuli in regards to the mitochondria itself when we talk about moderate intensity domain exercise and then extreme domain exercise? So we think about like all-out sprints, Wingate type protocols, or really hard 1 minute on, 4 or 5 minutes off. Is there actually a difference in what this does to the mitochondria? And if so, what is it?
Yeah, that's a really good question, and that's something that it's hard to answer. But I think there are differences in the adaptations that actually do occur. So, everything in physiology, especially the adaptations, is kind of like a mixing board equalizer, right? There's always some adaptations that are happening. It just depends on, like if you want the bass to be a little higher, the treble to be a little higher, those sort of things. So when we start to, as like coaches and physiologists start to argue, what's actually the best for, say, mitochondrial respiration, it comes down to some nuances, and the majority of the evidence at least from what I've seen, suggests that lower intensity, like so say moderate exercise, zone 2 training, those sort of things, seems to lead to greater expansion of the mitochondria within the skeletal muscle. And what that'll do is make a greater surface area for exchange of substrates and those sort of things. And also allow for adaptations for like fatty acid transport, right?
Stop me if I'm mistaken, but I recently read in a paper that it seems like the mitochondrial membranes serve as almost like highways for fatty acids and oxygen to be transported deeper inside the muscle and the mitochondria itself.
Yeah, that's a really good question. In that, I mean, I hadn't really thought about it like that, but yeah, I think that's pretty accurate because fatty acids are pretty charged particles, so they don't want to be in contact with say other fat, or like it's like you have to have facilitated transport of them. And the mitochondria, contrary to popular belief, are not bean shaped. They are a reticular network that kind of resemble the skeletal muscle itself. And we have some mitochondria that are kind of like on the outside of the skeletal muscle, and then we have mitochondria that are deeper. And it would make sense then that there are certainly binding proteins that can and do transfer, like fatty acids, like up and down, the mitochondrial reticulum. So yeah, it makes sense that they would act as like a trafficking network, especially for fatty acids. So by having more, right, by having a greater mitochondrial volume density, you would just have a better ability to transport and then get fatty acids into the mitochondria. So from that perspective, I think that's probably one of the reasons why zone 2 training is beneficial for say fatty acid oxidation, is because of that expansion. Whereas and don't get me wrong, like there's still more mitochondrial proteins that are being made with that expansion. There's better mitochondrial quality, all of those sort of things. But then on the flip side of things, like high intensity interval training, sprint interval training, all of that, that seems to stimulate more increases in electron transfer system and Krebs cycle proteins. So you can essentially oxidize more stuff. Like
is it more stuff per unit of time? I guess the rate of uptake, or the I guess I don't know, function is the word that comes to mind.
Yeah, it's more, I think if we say mitochondrial function, so it's like for the same amount of like protein, you have more ability to oxidize substrates. And we're still, and I say we, like the field is still trying to figure out, is that because of inherent changes to the proteins themselves? Is it because there's more proteins? Is it because these proteins are now kind of like forming together to create these super complexes? Other things like that. So it's still kind of like up in the air to be decided. Because it's a lot more complicated than I think all of us would have ever ever thought it was.
Once you get to that level, it's incredibly complex. I was reading, I think it was David Poole's recent review on essentially just the journey that oxygen takes from the capillaries into the mitochondria, and the different boundaries, barriers that it has to cross, and how we thought until recently that it was just a progressive gradient all the way down. And it actually seems like there's a lot more nuance and complexity in that. And it just, and even on such a simple thing as O2 going from hemoglobin into the mitochondria, it's crazy to think about this in isolation. And then you extrapolate to the system that we are, the system of systems that we are as an organism, and it's we can't really even start to wrap our heads around it.
Yeah, actually, I haven't read that review, so if you have it and wouldn't mind sending me a link, that would be awesome.
Yeah, I'll do that.
But yeah, that's that's what's so challenging about it is, taking this like kind of like deep biochemistry, physiology, and all of that, and then trying to make it as digestible as possible, right? Because, like for example, now we're measuring individual protein synthesis rates. So say for example, right, you have complex 1 in the mitochondria.
Mm-hmm.
That complex is made up of, I think, like 20 plus proteins. And each of those proteins is degraded at a different time depending on the diet and the exercise intervention that you're actually doing.
Mm-hmm.
So it's way, way, way more complicated than just like, oh yeah, there's more complex 1 after exercise.
Yeah.
And then so I'm humbled every single day looking at this stuff and trying to figure out what's actually going on and all of that. So that's why coming on and talking about this stuff, like with your podcast, with Matt on our podcast, like it helps to put things back into perspective of like, it's like, what's the application of all of this? Because there's some people in my field who devote their entire lives to changing one protein within the mitochondria and just seeing what it does.
Yeah.
And you're like, okay, well, how do we actually apply that? How do we translate that from, kind of like the bench science into like the actual like sport performance, or, just like health-based science and stuff like that.
Yeah, and I have one more bench science question for you, and then we can go into the more applied side. You were talking about different depths of the muscle, and relative to a given muscle group. Do you know of any significant differences in mitochondrial density or density volume at different depths of different muscles? The reason I ask this, and I don't know if you saw the video I did with Jem regarding the different Moxie trends on different skin folds and those kind of things. But essentially trying to understand what is the impact of the depth of the signal of the Moxie on what we might see on the graph, if that makes sense.
Yeah. No, that's always something that we are, especially using NIRS, have to be very aware of, is that depth of penetration could potentially affect what types of fibers we are actually interrogating. Yeah, this is a perfect graph of that. Is like, so what seems to happen is the deeper you go into the muscle, the more type 1 fibers you have.
Okay.
And then that would result, because that's in my mind's eye, that's where like the oxygenated blood is going to be. It's going to be easier for oxygen, diffusion from those oxygen rich arteries and those sort of things. And then as you kind of get more towards like the surface, then it appears that you have more type 2 fibers, which are less oxidative, more glycolytic. So they're not going to be as highly reliant on oxygen as your deeper fibers. And it's interesting that even like, I don't know what the difference is in the spacing of, like say low skin fold to high skin fold are. But it's interesting to me that you would get that disparate of SMO2 just based on spacing. I mean, it's completely possible, right? If you have,
I've seen it over and over.
It change.
Yeah, through all my testing, because I either see the bottom line or the top line or something in between with every athlete that I test. And usually, if there's the skin fold, I don't measure the skin fold at this point. Maybe I should start doing that. But usually women tend to carry a little bit more adipose tissue especially on the quads than men. And so usually you'll see a big difference there. And so when I test someone with a slightly higher skin fold, I tend to get a trend like the red one at the top. And for those listening to the audio, go to YouTube. We're looking at a picture on the screen, so you can check it out as well. one of Jem's beautiful graphs. And then when I test, say, a lean male, then I might get the bottom trend rather than the top one. And it's really apparent. And I had a big dilemma for a long time. I was like, okay, I thought we were looking for an increasing trend, in the moderate domain, and then a flat trend in the heavy domain, and then a descending trend in the severe domain. But for someone that works for the red kind of profile here, but for the blue profile, it's more of a flat down flat. What you say about fiber type distribution within the muscle, kind of muscle typology, if that's the correct word, makes sense given what I've seen and what Jem has measured as well, and what I've heard reported from other Moxie users as well. Do you think of anything else? Or does anything else come to mind when we look at that image and think about that, signal depth when it comes to measuring oxygen dynamics or kinetics?
Yeah, I mean, you always have to think about, the actual the skin blood flow, adipose tissue thickness blood flow, mainly skin blood flow, I would say, because like even with like the Moxie algorithm, right? It's supposed to get rid of kind of like the skin blood flow, and stuff like that. But with other NIRS devices, that you're still shining red light through a tissue that could be pretty saturated with with hemoglobin, because as you get warmer, you have to kind of shunt more blood to the skin. And so there's always something to kind of just have in the back of your mind. Oh, maybe there's some level of vasodilation within the skin that could be changing the optical properties of absorption there. But yeah, it's I think it's I would be really interested to see just like if somebody did like a core muscle sample, and then got like skin, adipose tissue, connective tissue, and then muscle, like what the actual, like how much the distribution change, like fiber type distribution changes even within, it's like the Moxie penetration depth, I'm pretty sure is like 1.25 centimeters, which really isn't that much. And yet, we're seeing these crazy different, responses. And I've seen the same thing. And it makes it really hard, especially like when you're, if you want to measure male and females in the same research project, like if you're getting different SMO2 responses, it makes it really hard to kind of compare those, and then also get, it's like not pretty data, but get data that's not like completely all over the place without significance and doesn't have any story to tell and those sort of things. So
yeah, I guess that's maybe a little call to Roger for the Moxie 6 version to include a way to measure the adipose tissue or the skin layer thickness, and then have different depths. Actually, the way we got to that train of thought with Jem was when he was looking at some data that he collected with the red sensor, train red, and what the device he had anyway had different depths of penetration of the signal. He had multiple signals, and the deeper one looked like a flat down flat trend, and then the more shallow one looked like an up flat down trend. And so we were like, oh, this is like the two profiles that we've been seeing over and over again, exemplified by those two different depths on the same person, right?
Yeah.
Which I guess we have to refine our approach and figure out how can we maybe normalize all of this. Is there a way to normalize it? It's probably getting multiple depths at once, and then model the whole spectrum of depth that you've. I don't know. That's beyond my reach, but
right.
Yeah.
No, I think so. That's something that Roger is definitely aware of, and him and I have talked about, making almost like a research grade Moxie in a sense, where you do have like larger depths of penetration, higher sampling rates, other things like that, because again, it would be worth it to see, and especially if NIRS is going to make a transition to more pathophysiological populations. it almost requires, like greater penetration depths, more powerful sensors, other things like that. So it's definitely on the radar. Everything in research and everything in, like development seems to go a little slower than what, users and stuff want.
Well, it's
But-
we have the easy end of the stick. We just have to use the stuff, right?
right.
Somebody's got to think of it and then make it. That's
Yeah.
I have a tremendous amount of appreciation for engineers like Roger, like Peter, that just come up with something not out of thin air, but I mean, obviously they have a lot of background experience that fed into those
Right.
projects, but they still created the damn thing from scratch, right?
Right.
So
Right.
I'm no one to say it's got to move faster, but I guess it's always good to have tech to look forward to
hmm
down the line. If we talk about application of those different principles and ideas we've been talking about,
hmm
so in the what would be the difference in, say, if we talk about intensity domains, what would be the difference between exercising in the moderate domain versus the heavy domain from a mitochondrial standpoint in terms of stimulation, in terms of work? Is there actually any difference when we talk about those different intensities of training?
Yeah, no, I certainly think there are differences, and going back to my kind of like equalizer soundboard reference. So, um, the same way that kind of adaptations occur, kind of in that distribution of equalizer. There's also internal factors that your muscle is responding to that then allow for those adaptations to occur. So,
Mhm.
we know that uh, NAD to NADH ratio, so redox balance, is an important factor for adaptation. We know that uh, kind of just like contractile stimulus, right? Strength of contraction is a good stimulus. ATP to ADP ratios are a good stimulus. Temperature, oxygen tension, so HIF1 alpha and in hypoxia. So yeah, certainly from that perspective, like a moderate intensity exercise is certainly going to yield a different internal stress than severe domain exercise. And this is something that I've really been thinking a lot about ever since that post I made on Instagram, where I was saying kind of, should we move to a 3-zone training model? And in all actuality, right, it's taking the 3 domains that we kind of see and then trying to estimate and figure out what sort of intensities delineate like the different physiological environments. Because there is certainly a difference between zone 2 training and then severe intensity exercise training. So we've kind of touched on this already, but zone 2 training, right? You're going to have, if we're thinking about kind of like those physiological internal stressors, you're going to have a high delivery, or you should have a high delivery of fatty acids to the mitochondria. You should have relatively stable but prolonged changes, or like relatively stable ADP to ATP ratio,
Mhm.
relatively stable NAD to NADH ratio. So from that perspective, it's kind of like you're stressing the system a little, but you're requiring that the system use more fatty acids. Whereas if you're on the flip side of things and you're doing like, say, all out sprints, you're going to have potential signaling of HIF1 alpha, like that's going to come destabilized, and that's going to have an impact on like the signaling within the cell. You're going to have greater changes in redox balance and ADP to ATP ratios, which is also going to cause kind of like more of a gradient sort slash stress. So that's going to and then you're also going to have higher pyruvate levels because of the reliance on glycolysis and all of that. So from that perspective, you're it's just different, you know, different flavors, right, of the stresses that are happening, right? One of them is like more prolonged. One of them is a little bit more extreme slash short, right? So those definitely have different outcomes in terms of the responses that we get, and that's why both are important.
Mhm.
There's people who argue it's like, oh, you should only you should do a lot of zone 2 training as like a cyclist, or oh, I only do hit training, sort of deal, right? Like there's always camps. The people come out and they're just like, well, this is the best, well, this is the best. And that's something that I don't think any good endurance coach in their right mind would ever say, oh, we just want you to do zone 2 training for the rest of your career.
Mhm.
And there's no good endurance training coach that's like, well, we just want to do, mile repeats for the rest of your career. So there's definitely, that's kind of where the art comes into it is, it's like, how do we maximize the stress on both sides, be able to then bounce back from it and adapt to it and continue to improve performance? Because at the end of the day, that's all that matters. Are you improving your endurance performance or not?
Mhm.
And I think that's what people get lost with. They're arguing about what modality is say best for mitochondrial adaptations. And it's like, well, is your performance getting better doing whatever you're doing? And if it is, then keep doing it until that it doesn't work anymore, and then tweak things, like very minorly to try to elicit more change. It doesn't matter if you're winning, like a Strava segment or anything like that. If you're not improving your endurance performance, or, I always say endurance performance, but it's just sport performance in general. But it's like, that's what I have to remind myself of. So,
Yeah, one way I've, I think, tried to frame it in my mind, and I'd be interested to hear your take on that, is that at least between maybe and all the different stimulus factors you brought up were really interesting to me, so I'll have to think about those a bit more. But what I've been thinking about is essentially the utility of low intensity training, especially in endurance sports. But
mhm.
that is a quality that is general and transfers really well to all sporting activities from my experience so far. It's just that there's such low fatigue cost to doing this intensity of work
Yeah.
that in my mind, what I was thinking is that maybe training in the heavy domain isn't that much different than training in the moderate domain. Maybe this, obviously, like you said, the severe domain's kind of a different beast, given the internal environment that we're evolving with. But heavy intensity is a bit stronger, so this may be more of a stimuli, but you
Mhm.
just cannot sustain it nearly as long. You can't accumulate as much volume as the moderate intensity stuff. So at the end of the
Right.
day, it's kind of whoever can put the most work in. We know it's tonnage for weightlifters, it's volume below threshold 1 for pretty much every long endurance sport. This is like one of
Mhm.
the most determining things when it comes to sport performance in those
Right.
endeavors. So it's just a matter of volume, and you just cannot match zone 2 volume with any other intensities, going upwards of threshold 1. Does that make any sense?
Yeah. No, yeah, that makes complete sense. And I'll tie this into some experience that I've had in the past. So there's always been, like whatever, say cross country, rowing, any sort of endurance background I've ever had, this is what I've noticed. There's generally two types of people within the team. There's the guys that run their easy runs hard, and then there's the guys that run their easy runs easy. And generally speaking, the guys that run the easy runs easy are the ones that are crushing it on race day.
Right.
And so from that perspective, yeah, I totally agree. I think that a lot of the times we get sucked into trying to do our easy stuff harder, and then we get an accumulation of fatigue that results in maladaptation, sickness, not sleeping well, other things like that. So I always err, especially on recovery days, zone 2 days, all of that, on the side of easy compared to doing it's like threshold work all the time. And yes, if you're one of those people who can accumulate that stress and that fatigue and that load, then you're going to improve more quickly generally than the people who just do like a little bit easier work like zone 2 stuff. But eventually there becomes a tipping point where that stress becomes too much and the fatigue accumulation is too large. And then you do wind up sick. You do wind up injured. And then how long, say you're injured for a month and you have to reduce your training load and training volume and all of that. While that other person who's just doing zone 2 training, right? It's just, kind of tortoise in the hair, just like the tortoise is just clipping along, doing their thing, getting like, slow gains over time, staying healthy, feeling mentally fit, all that sort of stuff. So yeah, I totally agree. I think that from that perspective, right? We were just saying, you get benefits from zone 2 and high intensity stuff, but I think like the high intensity stuff, like the severe domain should be done sparingly, and then a lot of what you do should be zone 2 or lower. Obviously if you're racing like an Ironman or a half Ironman, half marathon, those sort of things, you need to do some level of training within threshold because that's where you're going to be racing. But I don't think, especially for running, right? Since running is such like a pounding sport that you actually need to recover from. I think that a lot of the times people could reduce their intensity quite a bit. Like for example, we've talked about this like with like the VO2 Master. So I have one that's sitting right back here, and I did some VO2 max testing on a bike. And what I was doing essentially the entire, like worldwide COVID shutdown was just walking 10,000 steps a day. And up until that point, the highest my VO2 max had ever been was like 64, something like that. And then I get on the bike and do a quick step test, and I was measuring like low to mid 70s. And again, that could be differences in like the machine, like those sort of things. But like I I was in no way doing the same amount of intensity and the same amount of like, basically intensity. But I was keeping my volume pretty high by doing a lot of zone 2 zone 2 or lower training, just walking. And I think that actually played some good benefit, at least for my adaptation. If anything, it was just facilitating recovery more than anything. So yeah, that was a long-winded way of saying, yeah, I totally agree. I think that, we could do a lot more zone 2 stuff, err on the side of ease, and then when we are going to hit it hard.
Yeah, that's the way I like to approach it as well. If we're talking to an athlete, let's say maybe a combat sport or a CrossFit athlete who doesn't do any low intensity training, where do you recommend that they start? What is kind of the minimum effective dose to get going with this type of work? How long would it take to see, adaptations and returns on this kind of time investment? What's your approach there?
Yeah, if if a CrossFit athlete came to me and was like, yeah, like I've been doing CrossFit for a few years now, never do any zone 2 training or anything like that, what I would probably ask them to start doing is, accumulate a little bit more, say like volume, like, do like a 15-minute warm up at zone 2 or lower, and then do a 15-minute cool down at zone 2 or lower. Obviously you start to run into, kind of like potential effects of, well, I guess it also depends. Are there CrossFit workouts, like, do they actually take, some CrossFit workouts easy? And then does that turn into zone 2 work? Most likely not, because, like, let's be honest, most CrossFit athletes are type A individuals. They're like, I'm just going to go and crush it every single day. It's tough because I'm the same way, high ego, you get into a class setting, you want to beat your buddies because it's just fun to be able to have, bragging rights over them on any given workout. And I mean, I posted a reel the other day that was like, trying to convince, strength athletes and power athletes to do more zone 2 training. And it's just like, no, I'm good. It's a really hard ask. But I think it was either you or it was Matt who were talking about, like, what do you have to lose? Like, if you switch it for like 2 to 4 weeks and, you don't see good benefits, you don't see better recovery and stuff like that, just go back to what you were doing. So that's how I would, like, A, get them in the mindset to do it. And then B, I think the way that I would approach it is just be like, you can just add a little bit of zone 2 training, you probably want like 15 to 30 minutes, 30 minutes probably being a little bit more appropriate. Either before or after a workout. Obviously I wouldn't have that, like, if 30 minutes twice a week, would give them some sort of benefit because they're, like, say, that undertrained. I don't think they are, but then I would start to grow from there. And I think it would especially be beneficial. Like, say for instance, they weren't good at like the ski erg or something like that. It would just act as a little bit more supplemental training, go a little bit slower, develop that, like, technique, efficiency, other things like that. So it would be supplemental training, at least in the beginning. I can't really speak to combat sports because I've never really been involved with them. But I've thought a lot about it for CrossFit, and I talk to my gym owner all the time about it, and he's all gung ho on zone 2 stuff now, which is good. I'm glad he's coming around because he's seeing the importance of it.
Yeah, definitely can't hurt them. That's for sure.
Yeah.
I like your idea of tacking it either front or back on a workout that's already taken place. I usually tell them to just sit on the bike for 20 to 30 minutes 3 times a week post workout, and then dedicate one session a week to just going slow. And that's already a good 2 hours in the week that they weren't doing before, and that's going to help them within a few weeks. So and they usually, from my experience, they don't need much more, at least not to start.
Mm-hmm.
We know it's a volume game, but you don't need to start at 5 hours per week. You can start at 1 or 2 and then, build that over time. You were talking about 30 minutes. From a physiological standpoint, what are the grounds for that kind of minimum duration of this type of work? Or could you do, and I know there's a duration component that becomes interesting once you push it farther from a depleted glycogen uptake and fat oxidation kind of framework. But if we talk about the difference between 20 minutes and 30 or 40 minutes, is it the same if I were to do 3 times 20 minutes every day, or if I did 1 time 60 minutes every day? Why is 60 better? Because I don't believe we quite reach the glycogen depletion necessary to then kind of have that uptick in fat oxidation with those kind of time domains. What's your take on that?
Yeah, I would be, if it was, if you only had, say, 60 minutes to devote per week, I would say spread it out. Just because touching any aspect of, say, sport training multiple times a week is just going to give you, kind of coast the wheel. Like, once you get a wheel spinning, if you just like kind of tap it along, it helps a little bit more. So if we had to divide, if we had 60 minutes, you could either do it 1 time a week, 2 times a week, or 3. I would say probably 3. The reason why I say 30 minutes is, I think, like, 20 to 30 minutes kind of gives the body a chance to, try to reestablish some level of like homeostasis with substrate delivery, other things like that. Obviously that can happen within like 5 to 10. But I think that, the longer you kind of push that out, the longer you're kind of doing that, like, that lower level stress, which is then going to just, pull the system to adapt to that stress a little bit more. That's why I kind of lean towards like 30 minutes. A lot of the times what you see with, like moderate intensity continuous training, done in the literature, it's anywhere between like 30 and 60. And that just seems to be kind of the sweet spot. it might actually, if you're looking for, say, like glycogen depletion, or even, yeah, if you're looking for glycogen depletion, then you would probably want to do most of your workouts after, like a hard like WOD or something like that.
Mhm.
Because then you should be, fairly glycogen depleted. And then, going into it, it's like, then you can kind of stimulate that shift to fatty acid oxidation for ATP resynthesis and whatnot.
Yeah,
So
that's I like that. I like that train of thought, but at the same time, it's a double-edged sword because the internal environment you create by driving yourself into the ground for 15 minutes or whatever the workout of the day was,
right.
doesn't necessarily yield the internal environment that's benefit or that will facilitate fat oxidation if we have high levels of circulating lactate and they have a low clearance capacity. We know that lactate signals the body not to release as much fatty acids and oxidize
Yeah.
them. So that becomes kind of productive. But yeah, you have to kind of pick your poison, right? It's got to be before or
Yeah.
after because they're probably not going to dedicate 3 extra sessions a week to that.
Yeah.
So maybe mixing it up sometimes before, sometimes after.
Yeah, definitely. And to add to that, I think I mean, obviously, if you really, really bury yourself, you could have like high circulating lactate levels for quite a while. But a lot of the times, what we see is a pretty strong shift, even within a workout, from high carbohydrate oxidation to fatty acid oxidation, if you're allowing for adequate rest. Like, for instance, I just did kind of an interval workout the other day, and I was measuring, like RER of 1.1 and then, down to like 0.75 during like the rest and
Mhm.
stuff like that. And that's kind of where I think like doing, say, zone 2 or just even recovery training. It doesn't even have to be like as intense as zone 2 would be beneficial after, because what we see is that there's a high reliance on oxidative metabolism, so aerobic metabolism for ATP to restore phosphocreatine stores, and then work to resynthesize or synthesize glycogen within the muscle and all of that. And that actually requires ATP coming from the mitochondria in order to do it in the recovery phase. So even if it's not necessarily zone 2 training, just keeping like the oxygenated rich blood coming to the muscle and being exchanged is going to be beneficial by, say, doing that exercise, 20 minutes, whatever, after a hard bout of exercise. Yeah. So, and there's always something to say about, it's like you have to do a proper warm up in order to stimulate everything, get everything prepared, and then, doing a proper cool down as well. So yeah, I think that's just a good way, a proper warm up and a proper cool down are probably a good way of accumulating a little bit more of that volume in lower intensity. And, regardless of if you're actually doing, exactly the intensity at zone 2 or a little bit lower, you're still going to be stimulating fat oxidation, right? It's like people again want to argue, oh, well, what's like the exact optimal? Do I need to ride, like right at 120 beats per minute? And if I go over that, oh my gosh, I'm going to start losing my fatty acid oxidation. It's like, no, it's it's a curve. And you're still going to be stimulating a lot of fatty acid oxidation by just doing like 50 or 60% of your max heart rate.
Mhm.
So you can still gain benefits from it by
Yeah.
going easy.
Yeah, I've definitely been recommending. I guess following the zoning that I do with athletes, I'll then recommend middle of zone 2, bottom of zone 2, and then sometimes top of zone 2 for their low intensity training. So
Yeah.
it'll usually be middle. So
Yeah.
I don't want you anywhere near that first threshold just because
Right.
there's no point. It's not like threshold
No
training
extra
zone 4
benefit.
where you want to be
Yeah.
on the thing or right around there. We just want the internal environment to be maintained at low intensities to get all
Mhm.
the good stuff happening, right?
Yeah. Yeah, exactly. Don't accumulate too much fatigue. Stimulate a lot of, fatty acid oxidation and hopefully mitochondrial expansion based on that.
Mhm.
And yeah, I think again, I almost always try to recommend like go easier rather than harder. Like I've never had a day at CrossFit where I go in and I go harder than I was supposed to and be like, wow, that was a, that was a smart decision. Whereas like if I go easier, sometimes I can go easier and I'm just like, yeah, I feel freaking great after that. It's like I think I scaled appropriately. I think most things were in zone 2, even though it probably wasn't supposed to, because everyone else is laying on the floor like dead after the workout. But I'm like, oh yeah, that was great. That facilitated some good recovery there. And I think people they put too much emphasis on intensity sometimes, especially in the CrossFit realm.
Yeah.
It's always like, just go as hard as you possibly can.
But you, at some point when you've banged your head against the wall for multiple years and you stop progressing, then maybe I hope people don't have to get to that point to ask questions and optimize their training and do a bit more of the easy stuff to make the hard stuff easier. I had a story of a guy I've been working with for a while now. We did some testing a few months back, and he kind of shifted his approach to training CrossFit over the last few months. He said since December, he's done only kind of 10 WODs, like hard CrossFit style workouts, when he used to do multiple a week. And so over multiple months, he's done maybe two a month, if that. And the rest of the work is low intensity training, some structured work on energy systems, some weightlifting, some strict gymnastics, bodybuilding work. And his personal best on Fran was a 220. And he had achieved that previously by doing a specific Fran cycle, or I guess a training cycle focused on getting that test to a higher level. And he said he just recently did it again and got a 225. And he's done literally like 2 WODs a month for the last 6 months, and he's never felt so good. And he's like, wow, that really kind of, now I have to rethink everything that I thought I knew about, training for CrossFit, because it's not supposed to work like that. It's well, I guess it is, but not according to the way it's usually done. You don't need to push very hard to get some good adaptations if you do the work right, and if you're patient. I guess it does take patience.
No, that's something that I've always struggled with, with like the CrossFit, kind of like the mentality behind CrossFit is like, it's what, I don't even know what like the actual like slogan is, but it's like high intensity stuff all the time. And it just gets really challenging to actually do that day in and day out. And unless you are, like a CrossFit athlete that can dedicate, like their entire life, to all the recovery that's necessary in order to be able to compete and do that sort of stuff on a daily basis. Like, I think 2 to 3 WODs max a week is very, very adequate stimulus in order to get better, especially if you're, if your coaches are programming things appropriately, right?
That definitely plays a big role. And like you said, proper programming, lower intensity on most things means more volume too, and more repetitions. You get more movement efficiency, more economy, and all those things, matter when you're doing so much intensity and volume on different type of events, competitions, and workouts.
Yeah. I think the challenge is that a lot of the times, like zone 2 training isn't very sexy. So like, if people see like on the workout of the day, we're just going to do 30-minute row, really easy, working on form and stuff, they're like, well, I'm not going today. Like that's
people
stupid.
Are coming back now.
Yeah, exactly. So I think that's like kind of the, it's like the conundrum between, it's like, being a gym owner and programming is like, that zone 2 training is good, but then how do we make it like kind of sexy like those other workouts, right? In order to get people in the door and actually continuing to work out and exercise. That's it. That's a whole nother can of worms, but it's just like, CrossFit's just challenging in general.
It's a fun world to be part of. At least I'm enjoying getting to work with the athletes and talking to coaches. I think, mentalities are evolving and people are looking for things that make sense, maybe circling back to actually looking at other sports and what has allowed people to perform in other disciplines, whereas
Yeah.
it obviously depends on every single individual, but there was a lot of, at least in the early days, a lot less in the last few years, but early days CrossFit was very much, this is how we do things, and we don't really care about what other people do. But more and more that we're circling back to, oh, what are those sports
Yeah.
doing?
How do we actually learn from the years and years and years of coaching experience from other sports? And yeah, I mean, even in the level 1 CrossFit book, it's like, well, CrossFit can't be programmed because it's totally different than any other sport of its kind. Therefore, all the science that's been done before, doesn't really apply. Like that. I mean, that's like kind of some of the things that are said in like the actual book. And I'm just like, man, there seems like there's a fairly big gap here where we could, we as, say like the coaches / scientists could apply a lot of those training principles and physiological principles towards development in CrossFit. And I think Matt Fraser actually, going on the Rogan podcast and doing stuff like that and talking about his approaches to CrossFit really helped the sport move forward. Because he was like, oh yeah, I shit my bed, to the CrossFit games so I can sleep better. It's like, huh. And then everyone in the CrossFit community is like, what? Like, that's crazy. Sleep is important for a 5-day competition, or like eating a lot of carbohydrates. He's like, yeah, I eat candy bars when I'm doing, like 2 hours of zone 2 training. You're just like, yeah, I get it, especially if it's like, a little bit higher than zone 2 where you are using a lot of carbohydrates and whatnot. And those are all things that as an endurance athlete, you're just like, yeah, no duh. Like I always go out with my goose if I'm doing 2-3 hours of work, like those sort of things. And then,
Nothing
people
new
in
there.
CrossFit are like,
yeah, but it's good. Like you said, leaders in the sport trying to hopefully pull people in the right direction.
Oh yeah, for sure.
Phil, it's been a lot of fun, man. I feel like we touched on a lot of interesting topics from deep inside the mitochondria all the way up to training. So I appreciate you coming back onto the podcast. Where can people find you online? You've got a great Instagram account that you started a bunch of months ago, and you're posting really good content there for those interested in exercise physiology and all things human physiology and performance. So where can we find you?
Yeah, so on Instagram you can find me at critical02. That account is dedicated to just taking research, synthesizing different concepts, and hopefully teaching coaches and athletes how to best optimize their physiology. You can find the podcast, which we kind of touched on pretty much any podcast hosting site, Spotify, Apple, those sort of things. It's called Oxidative Potential. That's with Matt DeRoche. So him and I do one podcast together every week, and then he interviews a lot of awesome people, including yourself. So thanks again for having me on. And anyone who is interested, please reach out to me if you have questions about physiology, endurance training development, any sort of stuff like that. Like that's what my physiology / coaching Instagram account is all about, is trying to help people sort out all of the sort through the mud of the physiology research and hopefully come to some sort of application point.
Yeah, that's awesome, man. So you heard the man. Go follow him on Instagram, and if you have questions, you know where to find him. Phil, great pleasure, and I'll talk to you soon.
Yeah, likewise, Sean. See you later.
Take care, man. To this episode, if you would like to support the podcast, please take a few moments to leave a written review and a 5-star rating on Apple Podcasts. If you want to watch this episode again, you can find the full video recording on my YouTube channel. You'll also find hundreds of hours of free content, all my podcasts, my thoughts of the day, structured presentations, and more. So don't wait, go subscribe, and I'll see you in the next episode. Take care.